All right, so it's June 30th, 2023, and where I am located, we are once again inundated with smoke from fires. So, this is something that we've had two big episodes of this so far this year, and I think it was 2021. We had another big episode of it, although not nearly as bad as this because the smoke was coming from much farther away. But this is something that we've never had much of in this region, so everybody's all, talking about it. What's really, really interesting is about this concept, this number that people are throwing around called the air quality index. All right. Something that most of us never really probably took notice to in the past, unless you lived in an area where this was common. So, if we look here, it is about saying it's like 82 right now, which is, comparatively speaking, not bad. During the height of this whole ordeal, we probably hit 300 or 400 on that number. Now that number appears to be some sort of a scale that was developed based upon the effects of actual air pollution. So that number to me doesn't mean much, but what they do on these websites is they basically pull in data from monitoring stations all over the place. So there's a monitoring station a few miles away run by the state of Pennsylvania, and they monitor for particulate matter, which is just that. It's small particles and it's suspended in the air. And they measure that in concentration of micrograms per cubic meter. So a cubic meter is a volume of air that is about a yard by a yard by a yard, or a meter by a meter by a meter of volume. So it's like 27 cubic feet of air. So it's it's like a cardboard box, kind of like a washing machine. Think of that volume of air, and inside that volume of air, there is, say that the particulate matter concentration is 100 parts per, or micrograms per cubic meter. So that means that in that volume of air, you have 100 millionths of a gram. It's a really small quantity of material, really small amount of stuff in that volume of air. But you can tell in the situation, so right now we probably have a concentration of and depending upon the size of particles, it could be 80 to 100 micrograms. And I could barely see. It's very, very hazy. It's extremely hazy. I have a hill maybe a half a mile that way or 3/4 of a mile that way, and it's all just white. So in all that volume of air from here to there, those 100 micrograms per cubic meter really add up to something. They add up to blocking out a very large amount of the light transmission between my eye and that hill. Just that little bit of particulate matter. And it's also affects, I can feel respiratory wise, that there's something additional in the atmosphere, even at that concentration. At the height of this whole ordeal, we definitely had particulate matter concentrations well into the hundreds. 200, 300, 400 micrograms per cubic meter. And when it was at its height, the air actually took on the appearance of orange. It looked like you were on Mars or something like that, because there was so much particulate matter in the air that was optically changing the properties of the atmosphere, where visible light from the sun, we all know how these vivid sunsets and things have been going on in this area since the beginning of June because of all this particulate matter between the top of the atmosphere and surface. So, what else are we dealing with on a more long-term scale involving things in the atmosphere absorbing radiation. Climate change. A lot of people have a really, really hard time grasping climate change. And it's understandable because the gases that are involved are invisible. Unlike this stuff here, you can't see it, you can't smell it, you don't even know it's there. But the primary gas involved with climate change, what's going on? You got carbon dioxide. We're increasing the concentration of carbon dioxide just like we increase the concentration of the smoke. And carbon dioxide is present in the atmosphere prior to industrial human activity of 280 parts per million. So it's a different unit we use to measure CO2 because CO2 is a gas instead of a solid. But we can convert parts per million to micrograms per cubic meter. So 280 parts per million translates to about 500,000 micrograms per cubic meter. Not 500, 500,000. Since the mid 1800s, or the middle of that time, right when the Industrial Revolution really got started, we have increased the concentration from 280 parts per million to 425 parts per million, which corresponds to a micrograms per cubic meter of 765,000. So, if my smoke right now is at 75 to 100 micrograms per cubic meter, and the atmosphere contains 750,000 micrograms per cubic meter of carbon dioxide, it means the concentration of carbon dioxide is, what would that be? 10,000 times higher on a mass basis than this smoke. But you don't see it because your eyes aren't sensitive to the radiation that it's absorbing, and you don't smell it because your nose doesn't have a receptor that picks up carbon dioxide. So we think that it's not a big deal. It's not a big problem. But the fact is that it does the exact same thing optically to light as the smoke is doing. When you look outside and you can barely see a quarter mile away, you think, oh, it's absorbing or it's attenuating the transmission of radiation through the air. Carbon dioxide does the exact same thing, except the radiation wavelengths are in the infrared part of the spectrum that we can't see. So what happens is the Earth is warm and it radiates infrared radiation out all the way to the top of the atmosphere, out into space, and that's how the Earth gets rid of all 100% of its heat energy. So all the energy that comes in from the sun has to leave through the infrared radiation from the surface. So carbon dioxide in the atmosphere does the exact same thing to that radiation as this smoke is doing to visible light. It's absorbing it and making it so we can't see that distance. Now, the smoke is also reflecting it and scattering it in different directions as well, but it's optical. It's creating optical opacity, making so we can't see past a certain distance. And CO2 does the exact same thing as that, but in infrared, the far long wavelengths of infrared, at a concentration 10,000 times greater than this smoke. So imagine if you could sense that with your eye. And we might have different opinions in many people about that particular issue of the greenhouse effect and climate change, how that affects the energy balance of the Earth. So this is a really good analogy that I think is important to realize when you have something visible that you can see and understand from a sensory standpoint what's going on, and compare it to what's not visible to the human eye. And that's pretty much it.